thank you. I've been, this I think is my third or fourth time here. First time during daylight hours though. I think every other time it was like at the time of the year where it was dark, and so a really lovely setting. Great to be here. So yeah, I want to talk tonight about a project that I had the good fortune of working on a number of years ago in Embro, Ontario, which is sort of a rural community not far from Stratford, but sort of between Stratford and Woodstock. So yeah, this is a project that was done in 2022 by the Langlois family. They were the developers who did this project. And it might be unique in Ontario, if not Canada, in that it was there's no government grant money in this project, and it was done on spec, basically by a developer, a for-profit developer, to sell to the public. And they insisted on doing Passive House certified. So Mark Langlois is here. Thank you, Mark, for leading by example. There's nothing that Mark doesn't know about this project, so if you've got any additional questions after this presentation, feel free to talk to him. I should have asked you if that would be okay, Mark, before we did this.
I'm gonna let it slide.
Okay, so this is the finished product here, and today I want to focus on continuity. Continuity is kind of like the magic ingredient that goes into energy efficient design and construction, and basically what we have is a master document that was part of the planning process that basically outlines the building enclosure in section, showing the insulation details and the air barrier and the vapor control layers, and notes at every single intersection point. So how things are going to change from the wall system to the roof assembly, through the slab assembly, through the foundation walls. Maintaining insulation or air barrier continuity through similar components like wall to wall or floor to floor is not that complicated, but as soon as you change components it can get really tricky. The control layers often aren't in the same place, and it definitely has to be planned. It's not the type of thing that you can do that comes after the fact. This is just a breakdown of the units. There's 6 townhomes. 6 of them were slab on grade and 2 had basements, just because of the geography of the site. Just showing an example of the different notes associated with the different components and assemblies, and specifically stating exactly which layer is the air barrier layer and which is the vapor control layer. And then this is sort of a working document in our plan set. This is the actual, every critical connection is detailed in further detail. There's actually a red and a blue line, the red line for the air barrier, the blue line for the vapor control layer in this drawing that didn't come out very well, but they're in there in any event. Again, this is all very important at the planning phase. If you don't address these things, they're just not going to get fixed in the field. And there are details that need to be avoided. Sometimes they're unavoidable, but you need to have a strategy how you're going to deal with it. So starting with a slab assembly, this is a slab assembly that was done by, and again, this project had to meet Passive House certification under PHIUS. And so you can see the slab on grade, which is the same component assembly as it was in the basement units, but it's a leg-led slab on grade with 8 inches of EPS insulation underneath for R32, and the edge detail of it is such that it intersects with the wall insulation layer, so that there's continuity, this uninterrupted insulation wrapping around the entire building. There's a certificate just confirming that it is a Passive House certified component. This is what it looks like when it's being prepped. You've got the structural, you've got the steel in the assembly, and then the white EPS foam, and then the yellow membrane that you see there is the 10 mil air and vapor control layer. This is the slab assembly. This was ICF basement wall assembly with an additional layer of insulation on the outside, on the right-hand side that you can see, and the yellow control layer for vapor and air coming through the slab. You'll see later on how that interfaces with the wall assembly. This is a typical wall assembly. On the left-hand side, you can see the interior insulation on the cavity insulation on the inside, the air barrier and the air control layer in the middle, and then exterior insulation, continuous exterior insulation. This is a system also supplied by Legolat. This is the air barrier system, which was the zip sheathing with all the joints taped, and the 5-inch legolet system on top of that. On the right-hand side, you can see that there's some shading soffits up on the top right-hand corner here. I'll show you a little bit more about that here. So this is the one thing I would say is probably the most different thing about the type of building that everybody in this room has done or is doing. And that is maintaining continuity may require alternate construction sequencing. So I think that's an important thing. And again, that's something that needs to be addressed and identified at the planning stage. So if you look at this assembly here, you've got these shading soffits. A typical construction process would involve doing the framing, including those all at the same time. But now you've got an issue where you don't have continuous insulation where you wanted to have continuous insulation. So you have to frame the building, put up the air barrier and the sheathing, and then you have to not install those exterior details until after you've run the insulation in. So it seems simple. I mean, anybody can do that, but if you don't identify that as a key feature and then execute accordingly, you're going to run into problems. So the insulation went on continuously, there's no problem. And then we had to take a step back with the architect because the original design sort of had footings, had structural footings for these basically sun shading devices that didn't really need a structural footing. They were, in the end, the structural engineer was able to design something that we could just attach to the building. So the attic, the roof had two types of assemblies. There was a cathedral assembly or an unvented roof assembly, technically, and then a standard attic. So this is the attic detail here. You can see that in this drawing on the side, you've got the attic insulation. You also have the continuous insulation on the outside running to the top of that layer so that you have continuous coverage through the sheathing and the framing members of the trusses, all addressed by the exterior insulation here. Part of the assembly was an unvented assembly with a cathedral ceiling. And this is the interior that you're looking at here with the air control. Actually, this wasn't, I can't remember if this was a main, was this a main air barrier in this roof assembly? I think it was. This was the air and vapor control area in that particular part of the assembly. This is the back side of it. It actually did connect with the main attic space, so there was a pretty good amount of venting available. The windows were supplied by our friends here at Veta, and we're also Passive House certified. The casement windows and their doors, both with glazing and without. The devil's in the details for air barrier continuity. I'm just showing this not because they didn't do a good job, they actually did a great job, but this is a typical detail where in the corners where you've maybe different sheets of membrane coming together and you're trying to maintain continuity, it can be problematic to try and get it to go together properly. So this is the right thing to do and not leave it like what you see on the left here. A lot of careful detail through all the penetrations, again, to maintain. This is mostly for maintaining air barrier continuity. This is the exterior of the ICF foundation wall with the membrane on it. Years ago, I attended some functions, and I can't remember, I think you were there, that maybe it was even your project, I can't remember, but the best practice at the time was to put some sort of additional poly or membrane over an ICF foundation, that it was not as airtight as we all hoped it would be. Anyways, I've done it on several projects since, and it pays big dividends. It does. I mean, we didn't do a blower door test before to see how it was. Afterwards, we got really excellent airtightness. But anyways, if you're going to go through the process of putting a lot of effort and attention to all these other details, it's really not that much to do this last little bit. It was only on, I think, 2 faces of this foundation wall. This is just an example of the air barrier layer again before the exterior insulation is installed. This is the attic, the attic before it received its roof trusses. So all the air sealing has been done, and this is the attic floor, if you will. And to the right of it, you've got the trusses for the cathedral ceiling. And this is this open ceiling here would be the underside of this down below. But nonetheless, this would have had to be framed after all this air barrier material was installed and taped, which it was. This particular line here where you see the red, that carries through into the inside where it connects to this layer. So now you have the control layer coming through from the outside of the building to the inside of the building. Again, it was planned in advance. Everybody knew what the deal was, and it was executed nicely. That's just a sort of a close-up shot showing that particular detail, and it needed to be taped beforehand. Again, the framing guys have to be in the loop and understand that this needs to be sheathed and taped before we continue the framing. This is sort of the pre-verification worksheet for PHIUS, showing what the pre-certification target was. Our target was 22 kilowatt hours per square meter. 22.7, we were coming in at 22.5 with airtightness of 0.75. And in the end, with everything, we ended up at 19. And we ended up significantly lower, mostly because we got a great airtightness number. We came in our final test as just under 0.4 air changes per hour. Maybe there's some people in the room that aren't familiar with that, but that's very tight. I would say that you hear stories like that all the time now. Builders, I think, are really crushing air tightness now. The experience is really growing and building, and it's great to see that a lot of builders, a lot of projects are seeing these kinds of numbers now. So we're almost as good. No one will ever exceed this. This is the best ever, and no one will ever exceed it, but maybe someday somebody will. And that's basically it. I was the passive house consultant on this project. Again, it was a great opportunity. I think what I was trying to say before I had the malfunction there was that I think this is probably one of the first projects in Ontario that was done for resale. That was done on spec for resale. Certainly with a passive house certified project. So interesting, and I'm glad to have been part of it. It was a really great, fun project, great project team, and thank you for watching.